Okay, so AI Camp's been around for some time. This is our San Francisco chapter. You can actually scan the QR code and check in with us on LinkedIn. You can talk about the experience later down the line. But just to talk about the great collaboration we have with GitHub. We are here at GitHub once a month on average, and it's a great event. We really appreciate their support. And we're also at the Microsoft office in San Francisco too, around once a month as well. So we run around 2 events per month. And we are also starting to do hackathons and build out project teams that have interesting projects that they work on and try to facilitate that type of partnership and collaboration as well. And today we're here with Napsack, who's going to be speaking to you shortly, and Zilliz, who's going to be the first speaker of the evening, and then Addy as well, who will be speaking last at the end. So like I said, we are a global AI developer community. There are around 350,000 AI developers in 150 countries as part of the community, and that is growing with the obvious huge interest in the space. And the whole goal, the idea of what we're doing is to empower developers to learn and practice AI from anywhere, anytime, and obviously make the connections within the community. There are local chapters in 50 cities. If you go onto AI Camp, you will see all of the different events happening in these cities. So if you are traveling, do check in with AI Camp, because there may be an event that you can go to when you're on your travels, and there's plenty of pins here on this map. How to get involved. I'm a volunteer who works with the chapter and works with AI Camp. You can also volunteer in different ways. You can join a team of builders, of course. You can submit topics to speak as a presenter. You can sponsor the meetups as well, and collaborate on your events. And you can contact AI Camp for information on any way that you'd like to participate or you think you can contribute here at this email and email ID and the website, of course, as well. There's more events coming up. I mentioned we do a bunch every month. The next one is going to be the AI virtual seminar that we hold on Fridays. So that's obviously virtual. And then we've got the bi-weekly at GitHub, next one, 4th of June. And then the next hands-on workshop actually will be at the Microsoft office, 15th May. So that's going to be a little bit more hands-on. We did run our first hackathon. It was great just last week. And we're going to be hosting more. So do check us out if you're interested in taking part and actually building, and we'll facilitate those events as well more going forward. Thank you to the amazing clients and sponsors that have been helping us get to this stage and actually informing the community on all the amazing projects that they've been building and helping to provide support in terms of resources and venues like this. And lastly, we will talk a little bit about anyone who is looking for a project to work on, and you're interested in joining a project. Could you put your hands up if you're looking for an opportunity to work with a team on a project? Okay, great. There's a few hands up here. I'll see how many we can get to.
Hey, I'm Siva. I am working as an MLOps engineer at Cloudera, and I am interested in AI and LLM world. I'm looking for a project where I can leverage any LLM and build a AI agent, basically.
All right, thank you. I think I saw a couple more people over here.
Hi, I'm Akhil. I come from an operations world. Used to be a software engineer a long time ago, but went into operations. I'm looking for opportunities to either be a co-founder or to join a team that is trying to either go from 0 to 1 or to scale. I ran Uber North America driver side business on rideshare. I scaled another company from single-digit ARR to 120 ARR in 1 year. So I've had a lot of experience scaling and building things. And if somebody's looking to partner for a partner who understands the tech side, but can also be an operator to run sort of the business side of things, I would love to speak with you.
All right, thank you. Are there any others? Okay, I'm going to spread it around a little bit.
Hi, I'm Matthew. I'm product manager, product design and product strategist, and also former front-end engineer. I worked for one of the big banks building one of the conversational AIs. So I've been in this space for a number of years. So I'm used to working at scale, but I'm actually interested in something small, something tangible, something a smaller team to help. It doesn't matter what the context is. I'm kind of curious about running ideas off of others and just kind of experimenting. And I also have my own project that I'm working on that I'm looking at to help and have people help me with as well too.
Okay, and we'll do one more on this side of the room. And then I do note there was other hands up, so please, you know.
Do you want my notes?
Just up here.
Oh, I got you. It's fine.
Hi, I'm Praveen. I'm an engineer. Actually, I'm a consultant right now, so I do a lot of work with engineering, data science, and also with product management and just overall consulting. I'm looking for, really, I'm actually kind of open. I'm looking for fun projects that are building with communities with really great real world applications. So if you have some of that, like hit me up. So.
Okay, we've got more mics, so we don't have to wait. Okay, so I do want to switch now. Yeah, we should switch now, but there were other hands up, and please do, when I switch, you'll appreciate this because it's going to be people on the other side of that conversation that are looking for people to work with. So that's going to be, we want to give some time for that as well. So are there hands up for people that are looking? All right, there's a few. So you're looking for people to join your project, correct? Okay.
Hey, my name's Anish. I'm the founder and CEO of Lervo Learning. We're an AI ed tech startup building personalized learning and memory tools for students and eventually teachers. Our initial target market is medical students, so basically building a platform for them to learn and memorize easier, more efficiently, and personalized to them. We just launched our beta 2 weeks ago, and we're growing, getting users, and so we're looking for founding engineers and or technical co-founders to help us build out the platform. So yeah, my name's Anish, and Lervo Learning is the company. Thank you.
Awesome, congrats on the beta launch. Anyone else looking for anyone to join their project, looking for some input, looking for some hires? Okay, we're weighted more on the people looking than the people looking to bring people on board, which is fine. Okay, well, we'll move on now. Just lastly, I want to finish off by saying that you can communicate and with the broader community and with AI Camp via Slack and Discord as well. So please do scan the QR codes. And that's another way of keeping up with what we're doing at the events and so on and so forth. So without further ado, we'll actually move on. My name's Curtis Barker. I'm hosting with Devinder. We're working with AI Camp, and we appreciate you being here. So, Christy, if you can come up. We've got our first exciting speaker. Can you please give her a round of applause? It's Christy.
So I see a lot of familiar faces. I'm just curious, how many people were here just last week and saw me talk here? I see a few hands, yes, okay. How many people have heard about Milvus Vector Database? Okay, that's great. And how many people are using Milvus Vector Database? If you are, please speak to me because I also organize events and I would love to have you come speak at one of my events. So yeah, great. Okay, so with that, a fair number of people heard this talk last week. I was kind of like a last minute substitute because the person was sick. And so that's why I'm speaking 2 weeks in a row with pretty much the same demo. So what I'm going to do is kind of go quickly through slides and demo and then try to leave more time for Q&A so it's more interactive. So this is me. Feel free to connect to me. couple links here of interest, the GitHub. We are an open source vector database. So that's our GitHub. Please give us a star. We really need it. Also, Discord is where all the Milvus people are hanging out. All the cool kids hang out at Discord. And if you join our Discord chat, that's where people ask Milvus questions and get Milvus answers. We were founded in 2017. We're based at Redwood Shores, California. It is an open source project donated to the Linux Foundation. We have not only the open source vector database, we also have, well, a bunch of different open source projects listed here, but we also have the managed open source vector database. So you can write your code in Python. And for example, if you leave off the choice of index and leave it up to the default index, the auto index, in Milvus open source, that's going to be the Asian SW index. But then that same Python code, if you ran it on Zilliz, our managed cloud, it's going to get a proprietary, more bells and whistles, faster index. We have a ton of different indexes. I'll just touch on them briefly a little bit later. So roughly, I'm going to talk about hallucinations in RAG, a couple challenges of improving RAG. Surprisingly, there's still a lot we don't know and a lot of room for improvement in this pattern. And quick demo. So yeah, for example, here on Gemini, I asked list 3 politicians born in New York, and one of them listed is Hillary Clinton. And if you go to Wikipedia, you can see she was not born there. She was born in Chicago. So that's an example of a hallucination. And briefly, why do these LLM models hallucinate? It's because they're trained on tokens of sequences of words with masking so that they can predict masked words. And so, for example, if you're trying to predict that chicken walked across, it's probably the road, but because these large language models are trained on so much data, there could be all kinds of random stuff in their training data. And so sometimes you get random stuff out. Where do the models come from? They come from the next to last layer of a deep learning neural network model. And the reason is because the last layer is usually like 1 to 9 for the softmax answer, like 9 digits or 10 digits of prediction. But the next to last layer is where all of the knowledge is stored that model has learned. And so especially when we're talking about large language foundation models, this is really cool that everything that model has learned about everything it's been taught is in those weights. And it's crazy to think about. You can just think about this like a big f of x. This whole neural network is a big function. The x is the input, and the input these days can be pretty long sequences of words, and the output is going to be weights or numbers or floating point numbers, and the number of them depends on the model. It's called the embedding dimension of that model, and it's a fixed dimension. So typically, this is from the Transformers paper. The original attention is all you need. The transformer is composed of an encoder part and a decoder part. And these days in our modern GenAI, we've taken just the encoder part of that original transformer, and these are your embedding models. This is where you take that next to last layer in the embedding model, and that's your big f of x you can think of that transforms your inputs into a vector of floating points. The other part, the decoder, this is the GPT part, like the chat GPT, and the generative LLM part. These are only 2-dimensional vectors, but the idea is that those encoder models take the inputs, map them into weights, and these weights all together are forming their data points with, this is just 2D, but typically they're like 512 dimensions, 256 dimensions, 512, 1024, 1536 dimensions, a lot harder to visualize. But the concept is that vectors that are similar in concept should be closer in vector space. And this is the whole, this is what has made GenAI super easy and accessible for people, is that you can do these these vector calculations super fast and calculate cosine distances very fast. Okay, RAG is something you probably keep hearing about, retrieval augmented generation. This is because it's a really good entry point, because as great as all those foundation models are, they weren't trained on your data. And this is where everybody can come in and have their edge, because you are the only people who know about your data, who have access to your data, and can work with the GenAI models using your data. So this is an example, a pattern where, you know, there's training models and there's inference models. And RAG is all about inference. It's the quickest way to get results out. So what you do is you have your data, you pass it through an embedding model, which we saw was the big f of x that turns your data into chunks of vectors. And these are just arrays of numbers. You store those vectors in a vector database. You could store them in memory as well. At some point, you're probably going to need to save them a little bit more than just in memory. And then you have a search question, and the search question needs to be embedded with the exact same embedding model that you use for the rest of your data, because you're going to do cosine distance between the question and your data. And so those two things need to be two vectors in the same vector space for the distance to make sense. Then you get what's called retrieval. So you get the chunks of data out that are closest to matching your question in vector space. You get those chunks, you stuff them into a prompt. Stuffing is a technical term these days. And then that question plus context stuffed, you send it to like ChatGPT, for example, and you get hopefully a more reliable answer out than you would have without it, because now it got some context from your data to supplement the general world knowledge it has. So this is, it sounds pretty simple, but there's a lot of little nuances and choices you can make to improve this. The first thing is, a lot of people wonder, like, what embedding model should I use? I recommend, like, a really good place is this Hugging Face MTEB leaderboard. You can sort it descending by the column retrieval, which is the closest match to the task of a vector database search. And you'll see a bunch of models, and you'll also see the size of these models in terms of hyperparameters and in gigabyte size. So generally, I try to choose a model for just getting started that's small and that's highly ranked. And then another little tip that I just learned myself from one of my speakers at Unstructured Data is there's a thing that you can search for called tasks, and for example, he was searching for legal, with the keyword legal, and then you'll find like maybe a very small set of models, like 3 or 4 models that are ranked in terms of their specialty models for legal text embeddings. So that's another fun way to use this MTEB leaderboard. This main leaderboard, you do have to be careful because there's been some trickery lately. People are overfitting it. And if you took data science classes, you know overfitting is a bad thing. That's where people overfit on the training data. So they look great on the training data, but that means when you go to real data, you're not going to get what you expect or what's promised. So companies that like us, for example, that's one of our value adds, is we test all of these embedding models, and we only put the production ones as recommended ones, or incorporate them into our product. Another fun, interesting tidbit is this thing about that OpenAI came out with in February, the Text Embedding 3 series of embedding models. And what they've done is they've done something called MRL learning, and only embeddings that are trained with this step can get, you'll notice the same accuracy and an MTEB score between a 1536 length embedding and a 512 length embedding. And so this is a new little feature to watch out for. It's important to know, because if you can get the same accuracy with 512 dimensions instead of 1536 dimensions, you're saving on memory, and also you can serve up answers faster. So bigger is not always better for embedding models these days. The other thing is choosing your index, and we recommend, looking at the docs is a good way, because there's just going to be so many choices of indexes. If you're just getting started, kind of like the three main ones is flat. If you have a very small data and you want the absolute exhaustive search, a brute force that's the best answer, use flat if you've got small data. Typically, you don't have small data, so you want to go for something like IVF flat, which is a cluster algorithm for finding nearest neighbors, or HNSW, which is kind of pretty much the go-to these days for vector databases. It stands for Hierarchical Navigable Small World, and it's a skip list of graphs, which is very fast and very accurate. And then there's going to be specialty indexes. For example, we have sparse indexes, which are kind of mimicking what keyword search did in the old days. Binary indexes are kind of the latest wave, because they're very tiny, and so they're probably good for phones and things like that. If your data is huge and can't fit in memory, then it can overflow onto your disk with disk ANN. And then, of course, if you've got GPUs, we have hardware optimized for different GPU ARM architecture indexes. Just a little bit of intuition here. So the IVF flat, what it does, there's a hyperparameter n list, and that's like where you say, how many clusters do I want to put my data into? And then when you do ANN search, which is a stochastic method, you're not guaranteed to find the absolute nearest neighbor, but approximate nearest neighbor will search there's a certain number of clusters for the nearest neighbor. Hierarchical Navigable Small World, high level, what it's doing is you have this hyperparameter M, and M tells you how many layers you want to put into, you split up your data into, and that's going to determine how sparse that top layer is and how dense, and how many layers you're going to get to. The bottom layer always has all the data. And so what happens is when you start at the top layer, I've only got 2 data points here in my drawing, but so it's super fast to find the nearest neighbor in the top layer. And then you'll jump down to the next layer and then again find the nearest neighbors from there. And because you've split up the data this way, you're jumping really fast layer to layer, and each layer it's a small number of, you've restricted the number of nearest neighbors you have to search, which makes it super fast. So yeah, Yuri Malkov is the author of that paper. He came and spoke at Unstructured Data a couple months ago. Chunking is another interesting and just really not well understood topic. So similar to in data science, when we had the kind of data science art of data featureization, where you had features like red, blue, green, and you had to turn those into numbers. There's all kinds of different ways to turn those features into numbers. Something similar is happening here with chunking. So basically, depending on what kind of data you have, there's different chunking strategies that are going to be the most efficient. I'm going to talk about, my demo is going to be the docs. So I have technical docs. They're HTML files. And one trick, for example, just to get your brain thinking about this problem, is like you've got a web page, and typically you take like 512 length chunks, character chunks, and with a little overlap. And if you think about it, there's actually more stuff. You've got headers in there in that HTML file. So why not just stuff those headers? Because they're very short. And it's kind of a trick way of getting more context into your chunks, is just to stuff those headers into your chunks. Not much extra in terms of length of chunking, because they're short, and you're just kind of cheating in a way to get a lot more context about what those chunks are about. And another little, for me, if I hear about the chunking strategy, I typically check a llama index or LangChain to see if they've implemented it. If they've implemented it, it's probably a good clue that those are probably worthwhile chunking strategies to look into. I'm not going to show the code because I'll just briefly show it. And I think at this point, I don't know, I'm just going to jump into my demo. Just another kind of high level concept about the way vector search is going. We were used to thinking about keywords, and this is called these days sparse vectors. So a keyword is when you have like a very specific word, like your product name is blah 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 blah, and this you're going to find this, you want exactly that word. That's keyword search. Semantic search is really good for the situations where you suspect that there might not be those exact words, like the word, like you are looking for wiki how articles about fixing leaky taps or drippy faucets. You're not worried about exactly the right words, but you want to get things that are semantically related that mean the same thing. So two different reasons for two different types of search. In the past, they've been very different technologies. These days, they're all becoming unified into vector search. So sparse vectors and dense vectors for semantics. So sparse vector search, basically it's taking where we used to have an exact weight for every single word. So each word had a unique number. Then we went to those TF-IDF and BM25, and then Splade is where we used BERT bioencoders to calculate weights based on context. And we thought, oh, look at us, we're really smart now. But then those like Splade and BERT did not generalize to out of context. So you show some new words and it wouldn't really understand them. So nowadays, this latest sparse is BGEM3, and it does understand and generalize to out of domain keyword search. So what we do is it's called a re-ranking, when you take a sparse vector search and a dense vector search and put them together into an improved overall list. Lots of terminology about re-rankers, whether they're calculated before, those are called early interaction models like BERT, or whether they're calculated after you have your top K lists, those are called late interaction. And then the drawback used to be that there's all of this calculation that has to happen on the fly, which slows down your query. Nowadays, there was just one small tweak to do the late interaction, but calculate them offline. So you get the best of all worlds, the re-ranking and fast performance. So I'm trying to draw a picture of that here. This is BERT on the left, where you're looking within the document, within your own data. And then this is re-ranking, where you have K candidates and you want to come up with a smaller list of top K. And this is another picture of the same thing. You got your data, you do a search, maybe with a metadata filter, like we can do in Milvus, and then you do a re-ranker, and it takes all of these, maybe several lists of top Ks, and converts them to a single list of smaller top Ks. Okay, with that, I'm going to, and I guess, sorry, one more thing is, if you do look at the research papers and you look at all of the stuff that they've done with re-rankers, we're really not talking about huge differences here. So yeah, I think that's just something to keep in mind, is like we're talking about maybe 2% difference. And there's like more bang for your buck in other areas, which I'll show you. Okay, so just a quick little glimpse of what it looks like to code a demo here. I've taken all the Milvus documentation and downloaded them, all the Milvus.io docs, and put them into a local folder. And then I can use the LangChain directory loader to read all those HTML files. And all of our docs, which seem so complex, is only 22 files. Then I'm going to start up a local Milvus. I'm running it on Docker. Sometimes I demo it with Zilliz. It's pretty much the same thing, or not the same thing, but pretty easy as well. But I started up a local Docker. I define, I just connect to it and then check its version. One thing is to make sure you apply Milvus. SDK major minor versions match. So even though this is 2.4 SDK and I've got a release candidate here for my server, these will work together because the major and minor are matching. And then I've got some code in this notebook, and I'll send it out through AI Camp, how you could connect to a Zilliz cloud cluster if you want. And then I will go ahead and load an embedding model. So I'm going to load that latest one that we talked about, the BGEM3. We already integrated it into Milvus. So when all I have to do is just import the embedding function. Say that I'm running CPU and check the dimensions. So the dense dimension is 1024 here. The sparse dimension is going to be 250,000, but mostly zeros. And the Colbert, which is the neural reranking dimension, is 1024 as well. Okay, create a collection, add the index. I'm going to add HNSW to my index. And I also have to specify my sparse and dense vector where I pass in the 1024 dim to my dense vector. Create my HNSW. So, yep, I dropped it, created it. Now the chunking step. So I'm going to do a simple chunking step first, which is chunk size 512 with a 10% overlap. And I use the LangChain. This is the recursive character text splitter, and split it. And that's called my simple chunking. So what I did is I took original 22 docs and split them up into 362 chunks. Now I'm going to apply the HTML chunking. So what you do here is you just define, like, I'm going to have an H1 and H2 headers. I'm going to declare my LangChain HTML header text splitter to split on. The strategy is keep stuff within headers all together in one chunk unless it's too long. Otherwise, then call the child splitter and split the rest. So what this does is it splits 22 docs into, I'm surprised it said 22. Oh, no, I'm reading it wrong. 22 docs were split into 304 chunks. Okay, so slightly different. You can tell something different happened. And then I always like to, as best practice, make sure that I've parsed my sources so that I can cite them correctly. And that looks like that worked. Go ahead, and now all I have to do is just put them into a list, and I'm going to just insert these things, which is now chunk, header, source, and two vectors. So I'm going to put those into a list of dictionaries and insert them. It takes less than 1 minute, 23 seconds. Less than one second to insert those. This is another question I see sometimes come up on our Discord: is why is my embedding and why is inserting is the naive question. Why is inserting taking so long? And it's a lot of times because they've done chunk and insert in the same step. Chunking is what takes more time. Insert should be super fast. Okay. Yeah. So I'm going to skip and go to the good stuff and do a vector search. So I'm going to have a question, and this is the API just to pass the question. So you'll notice with this BGEM3 API, we have a choice to re-rank what kind of re-ranker you want. And I said for my top K, I only said 2, for example. So I'll just submit the API query. I'll get back 2 documents. I'm going to assemble them together. This is me checking the rebankers that I really only saw differences in the 7th through 10th positions of my retrieved text. So rebanking in this case wouldn't have helped me. And now I take all of my contexts and I put them together, set my temperature, random seed, frequency penalty for my LLM. And now the fun part, I can try all these different LLMs, and all I'm going to do is stuff that context that I retrieved with the sources into the LLM's prompt. So here I took, this is really cool if you haven't tried it. Ollama lets you access these open source LLMs like Llama 3, which came out 2 weeks ago. Just you can, and it'll make it run on my CPU. For example, this GGUF means it's for my CPU. GGML would mean it's for GPU. And then I can see that I'm running the 8 billion instruct version of Llama 3 with a quantization level Q4. And if you're a curious type like me, I have in my notebook where you can look up what these quantization levels mean. But basically, I've got the highest level of quantization because I've got the poor person's laptop of 16 gigabytes RAM for me. Okay, so here's the prompts. I stuff the sources and the context into my prompt and submit it, and I get an answer out. And it looks pretty good. I can see M, EF, and EF construction are the hyperparameters. Could also just simply try Anthropic. Just before Llama 3, they were the new kids on the block. So same thing, same pattern, ask a question, stuff the contexts and sources, submit it. And I'm not gonna do it right now because it's kind of expensive. But yeah, I get an answer out, and I save my answers and all of how much it costs. So you can see Haiku is the cheapest. It's even cheaper than GPT 3.5, but these other 2 models are a little too expensive for me. Like Opus was costing $15 per million tokens instead of 50 cents. So not for creating a demo. Okay, and then Mixtral, I also just tried that one as well. Now the Ollama version, unfortunately, is as small as I can get it, is still 48 gigs of RAM, which I don't have. So I tried out AnyScale endpoints just the other day for the first time, and it's surprisingly easy. So I put instructions here to follow how you can how you install AnyScale endpoints, and then you can go to this website console.anyscale.com v2, I guess, playground to try out different models. And so I tried out the Mixtral there. Same thing, and I get a really good answer. So that's kind of the end of my demo. Just RAG, that's how RAG works. And sorry if you heard it many, many times. I hope it helped. Thanks. Yeah.
Are there any questions? And thanks again, that was a great presentation. Any questions on the presentation?
I have a question on ingestion. So you shared that when you're ingesting your headers, header 1, header 2, and then sparse and dense vectors. Are you differentiating between header 1, header 2, and sparse vectors, or aren't you just throwing everything into like an embedding, function? I just using the embedder.
Right, yeah. So the input is going to be the same, whether it's a sparse embedder or a dense embedder. It's still like they're both f of x's, and your x's are still the same inputs, chunks of text in this case. If you're doing images, they could be chunks of images, but for all purpose, they're unstructured data basically. So the x's are the same. The functions are different, whether it's a sparse embedder or a dense embedder, and then they get re-ranked together.
I guess for clarification, are you concatenating the headers and the bodies into one?
Yes, technical term, stuffing. So I'm taking H1 space H2 space chunk of text.
Thank you for the questions. Any other questions? Any other? Okay, another one, and maybe we'll fit in one more after this.
Hey, so you mentioned that during the chunking step, you mentioned an overlap of 10%. Can you elaborate on that?
This is, some researchers have come up with this as a rule of thumb, and I don't even know where the 512 comes from. It's just like a natural human length of text that seems to be a recommendation for. Now, of course, it's going to depend on what kind of data it is. Maybe lawyers are more long-winded, and maybe 512 is too short for them. But 512 seems to be the general default for chunking with a 10% overlap. It came from Andrew Ng, I believe, the very first time, and people just kind of stick with that. There's all kinds of extra rules for it, and this is why I feel like it's kind of a dark art, this chunking stuff.
Thank you.
Okay, any final questions? We've got one over here. We'll take one more.
Thank you for the presentation. I have a smaller scope question that expands to a slightly larger one. So the smaller one is, you mentioned some of the indexing strategies, and I was curious about maybe broadly speaking, the trade-offs that we would be striking in terms of choosing different indexes, and how do you optimize for which one best matches your desired outcomes? And the second, more general question builds on top of optimizing the different parameters to meet your desired outcomes. And I'm curious about how you might advise, like kind of building some kind of evaluation pipeline to, you want to tweak like your chunk size, you might want to tweak your chunking strategy, and then you need a way using, I guess, keeping other things constant, you need a way to figure out what are the optimal inputs for your data. Thank you.
Okay, so I'm going to refer you to our docs for the different trade-offs. So basically, like if you were to think about the M in parameter in the HNSW, that's going to affect memory. If you think about the EF and EF construction parameters, that's going to affect latency and accuracy. But I didn't get to this part where this was one of my guest speakers at Unstructured Data, the co-founders of this company, Exploding Gradients, and their open source project, RAGis, is a method to evaluate RAG pipelines, and they use the concept of LLM as a judge. Am I running out of time? Oh, no, you're not. And I'm not showing my screen. Well, oops.
But yes, you are running out of time.
Last time it just worked magically. Oh, there it goes. Okay. So anyway, so I ran through what I demoed here. And long story short, what I came up with in the end was I measured the accuracy that I get out when I use the simple chunking strategy versus the HTML splitter, and I got a 34% improvement. And then I measure the improvement that I get by changing my LLMs, and I get much smaller, like the max was 9% improvement, but 9% improvement. So this is where I would say chunking strategy is probably more worth your time.
Okay, thank you, Christy from Zilliz. A round of applause again, please. Thank you so much. Okay, now we're going to have Mark from Napsack and Cooper as well. A round of applause for Mark and Cooper from Napsack. This should be great.
So while Cooper is getting set up, we'll do some brief introductions. So Cooper's going to tell you a little bit more of his story, but my story is I started several companies and most recently worked in fintech and crypto, a company called PayJoy and a company called Stellar Development Foundation. And I had this really interesting experience where these very tech-forward companies did not allow you to use AI at work. And Cooper had a very similar experience from talking to people. And so we set out to try to solve that problem, a very counterintuitive problem.
Thanks, Mark. Hi, everyone. I'm Cooper, founder and CEO at Knap. I'm going to talk about a couple things tonight. First, the problem that we've faced, seen ourselves, the solution we came up with, Napsack, and then also going to share with you just briefly an open source repository, as of today, open source repository, powering part of Napsack and what you can build with it. And then hopefully there's time for Q&A at the end. But yeah, I before starting Knap, I was an AI researcher at Lambda, doing diffusion models, transformers, that kind of thing. And in the months after ChatGPT's launch, I think really the what we saw was almost like an obligation to make yourself more productive using AI. Ideally you'd be a 10x whatever PM engineer, so that you're not the guy on the left who's not using AI at work. But I think reality set in, like it's pretty complicated, right? Like there's just a lot of hoops to jump through. There's a lot of data sources that maybe need to be integrated. Every agentic AI startup needs access to Gmail and G Suite and such. Maybe just as like a show of hands, how many people use AI daily at work in some form or fashion? Maybe like 80% or so. How many of you have faced some form of restrictions or such, maybe from InfoSec and trying to get AI at work? Maybe I see a good number. Certainly that was our experience. It's easy if you're a dev, you can run Ollama locally if your MacBook is big enough. But otherwise, it's not so simple. And generally, this is, as we've talked with people, this is the thing we've seen. Chief information security officers generally are pretty hesitant to give access, especially in certain industries like finance and healthcare. But even more broadly, like at our workplaces in tech. This is a slide from Dropbox Dash, think semantic search, AI chat application that requires a lot of data integrations, many of which are very sensitive. And I think employees are put in a tough spot. I think they've got like two options. They can play it safe and listen to company guidelines and not use the tool that they want to. Or alternatively, it's kind of don't ask, don't tell. Hopefully I don't get caught. And really, this is not a great position for enterprises, right? Like, I guess the two solutions are, we go and sign, some expensive, complicated Azure or OpenAI service agreement, get SOC 2 compliance, or make sure all of these startups with agentic AI are doing that. Or, I don't know. Yes, this is really the inspiration here. Or the problem we wanted to tackle. There's plenty of, I guess to summarize, there's plenty of easy to use AI solutions that aren't private. Think custom GPTs. There's more complicated, expensive things you can do to maintain privacy. Really not, great for non-technical audience. There's also some solutions that are just kind of not easy and not private. But we're hoping to provide something that gets both of these benefits. And the start of how we built our solution was noticing this trend among a couple others, but certainly local compute is increasingly AI optimized. I don't know if anyone would have guessed 4 years ago how much RAM would be in a M2 or M3 Ultra MacBook. It's impressive, right? The GPU power as well is beating a lot of the NVIDIA offerings even. I keep forgetting about this slide. Yeah, it's really fast, our solution. So we've built a desktop app that is in private beta at the moment. So you're welcome, if you'd like, to join the waitlist. We're rolling it out to more and more users. I'll give a demo in just a second. It is, last thing, I guess, people who sign up tonight, you will be prioritized as we roll this out. So, if it's interesting, we'd love to get this out to you and hear from you how it's going. Okay, let me transition over here. It's just showing exactly my screen. I compressed my whole desktop into this folder. If anybody, okay, where is my? All right, so this is the main screen of the application. It's accessible via just Command K. supposed to be reminiscent of Spotlight. This felt like the right entry point for a lot of people. I'm using ChatGPT enough that this is what I wish I had with it, right? That I could just instantly on my computer go and ask and get what I need. I just realized this is going to be hard with a mic. Mark, do you want to hold this? I've got to do a lot of typing now. It might have to be kind of close. Okay, we'll get this right. So the first thing you notice, it's on this local files tab here. This is on startup, Napsack indexes your computer. It asks you for permissions, of course, but you should be able to find in a Spotlight. Oh, it's not a demo without a crash, is it? Give me 1 second.
Any song requests? Some poetry.
Let me skip through these initial screens here. So while this is loading, you'll see there's a few tabs. It's indexing files in the background. We've got local files for a RAG type experience. There's local AI for just straight AI chat. Hopefully we've got stuff showing up now. So you can see the speed is pretty good. We've got a combined fuzzy and semantic search. So, traditional like index documents locally, as well as semantic meaning in a hybrid kind of fashion. Let me see here, like I've got some, fake contract here. You'll notice we've got some extracted info. This is LLM generated, all locally. A general summary, some categories that we've extracted as well. And in the bottom right here, there's this ask a follow-up question section. This is where you can interact with the Napsack AI agent. This is a custom agent.
Shut off your Wi-Fi.
Oh, that does not require Wi-Fi, so I can get rid of that. This is not querying an API. Okay. Let's ask some basic questions about this, like what are the terms of this contract? I think is the font good? It's pretty good. You'll see it's pretty snappy. This is definitely faster than GPT-4. Maybe it's a little faster than 3.5. Semantic understanding is pretty good. I can get more detailed. What is the initial deposit in the agreement? That is correct. What about like, one I'm always asking is like, are there any legal red flags I should be concerned about here? This is something I wouldn't want to upload to GPT-4 or Anthropic or whatever, but is honestly pretty useful for my day-to-day. I guess another classic example of something that I would never upload is a W-2. This is not my real W-2, though there is a real one down there that we're not going to fixate on. I guess just high level, like what was my wage in 2023? Yes. How much was withheld in state and federal income tax? Sure. Let's see. Yeah, that looks right. Translate the doc into Spanish, output in Markdown. Nice. Typical LLM things, but on your files locally, and honestly, pretty snappy.
What are you running? Tell people what computer you're running.
What computer am I running?
Memory.
Wait, what do you mean? Like
the RAM.
Oh, like RAM usage. Sure, I can show that actually. This is not. I mean, this is a decent MacBook. You'll see M3 Max, but I'm using very, not the memory pressure is low still. I guess we can keep this. I'll just keep it up here actually, as we do stuff. So there's, so that's the first tab. Think RAG on your local private files. Expect in future releases, multi-document support, whatever people want. There's another tab, local AI. This is the kind of stuff that doesn't require RAG, but you still maybe wouldn't want to put into ChatGPT, or honestly just want it at faster, on a hotkey. Like, what's a good question? My boss is mad at me. How do I diffuse the situation? Okay, a little verbose, but sure. Thanks, LLM. Let's see. Yeah, just for the sake of time, I'll move on. There's a couple other tabs you'll see here. One is called Archive, which maybe doesn't feel like it fits the theme. And there's another one that's Add Connector. So I'm just going to spend a little time talking about these. The Archive connector is built with this repository that we've open sourced. It is, the goal is to have an easier way to do some data ETLs for, vector DB and LLM situations. So currently, if I start typing, this is, what Christy was just talking about. This is semantic search over a vector database. It's not using Milvus, I'm sorry. But it, would love a PR for Milvus integration, but you'll see it's also extremely snappy. This is just about at keystroke speed. And I'm getting pretty reasonable results. So let's just like, clip transformer. This, I should get some results relating to like vision. Yeah, maybe a few. Vision transformer down here. Diffusion models. These are all archive papers that we've embedded with the Napsack connectors repo. They are. Let's see, I think it's going back to like 2015 or something, all papers published with the artificial intelligence category. And you'll see the same, similar stuff, extracted categories, summaries, and so forth, and a place to ask follow-up questions. So yeah, that's the experience currently. It's been, a good amount of time getting this ready for you for this demo. Sorry, 1 second. Back to the slides briefly. Oh, right, Wi-Fi is down since I turned it off. There we go. Right, okay. So just a little bit about engineering decisions. The app is actually built with a Rust backend and not a, not in Swift, web stack front end. The main, actually I can take this now. It should be good. Thanks, Mark. The app is actually built with a Rust backend, web stack front end. Part of the reason here, the reasoning for this is, you may have seen this Greg Brockman tweet that sums it up pretty well. Much of modern ML engineering is making Python not be your bottleneck. This is definitely proven true. It's, LangChain, Llama Index are amazing to hack with. It's tougher to get it working in a production environment. We've struggled with like global interpreter lock, other things. It's also definitely difficult to package. If you're a dev, you've got a Python executable on your computer. But if you're not, it's really hard to package these things for somebody to use on their laptop, and in such a way that, as you saw, uses minimal memory and CPU. So there's a lot of optimizations here. Rust is great for that. Let's see. I think that's everything on the Napsack app that I wanted to show. You've seen the waitlist already. You can also go to knap.ai for that. This repo that I was talking about, how do I go full screen here? There we go. Let me blow that up a little bit. It's knap-ai/knapsack, changing pretty materially day to day, definitely under active construction. But, the gist is we're integrating more and more connectors, think ETL plus LLM in the loop, so that you can, do stuff like the archive connector that I demonstrated in the Napsack application. So certainly, if people give us PRs for connectors they'd like to see, we'll make sure those show up in the application. But this is also meant to be something that you can, Docker compose and run yourself to be extracting things like, say, archive research papers every 5 minutes. So let me show you just to end just a little bit of that. I should also blow this up. Okay, I need to type again, but I don't need to type much. It's okay. You can stay seated, Mark. So yeah, it's pretty easy to set up. On the left is just a config file. It's not super important, but you can see like there's archive connector. That is what I demoed to you. Yeah, it is indeed. I'm extracting all files between 2015 and 2024 in the artificial intelligence category. And it's this connector is running every 5 minutes. You see some details here. Quadrant, which is, I've really enjoyed as a vector database. Actually, one of the embedding models that showed up in Christy's demo. And on the right, yeah, just you see how easy it is to employ Napsack here as a Python library. There's some boilerplate here, but you see instantiate Napsack and run. I have it commented out just because the archive API is slow. And you can start running semantic search instantly on up-to-date data. So just, I'm going to put the mic down again and just show you how fast this is. Actually, I don't need to put the mic down. It's got to load the embedding model, but after that, it's quite snappy. So I'm just querying clip transformers over the archive connector in the Quadrant database, and pretty awesome. You see, I see some. This one, I don't know how relevant this one is. Actually, maybe we need to tune, but yeah, you see transformers here. You see RAG stuff. Anyways, you get the idea. You're definitely excited to see what people build with this, and keep an eye on it. We're going to be updating it heavily over the coming weeks. I think that's just about everything. Let me see what else I've got here. Okay, I don't know why the screen is dark. There we go. Okay, last but not least, we have a Discord where you can get help, tell us about issues, and once we start rolling out Napsack, the application, would love to hear feedback. I think that's everything from us. I guess we can open it up for Q&A now, but thank you guys for coming out and listening, and I'm looking forward to chatting afterwards.
Thank you so much, Cooper. Okay, some Q&A. Any questions in the audience? Okay, we got one here.
You have a question. Help me understand how this is different than, say, I'm at work and I'm just using ChatGPT. So how is this different or better?
Yeah, obviously a different model. We have a custom fine-tuned model, particularly for these use cases. Clearly not a foundation model as it's running locally, but the privacy concerns that one might have with uploading proprietary data, you don't have to worry about any of that. Yeah, you don't need a subscription to we're not paid. You don't need a subscription to the best tier of model. Yeah, just to name a few.
Great, thanks.
I saw one question over here. Oh, and one back there too.
Hi, my name is Harsha. So you have demonstrated with a PDF documents and stuff like that. So what about like actual code and these kind of searches? Can this do local searching?
Yeah. So yeah, we don't. Yeah, you probably didn't see any code files show up. We're currently not indexing those. There's no reason not to. The AI would work on code as well and could do code generation. That's just not the initial use case we've addressed. I think if the feedback came in that people would love to see this, for code, definitely. I mean, that's certainly one of the best applications for LLMs currently. But at the moment, yeah, we're not indexing code.
So it means only for certain kind of document and data, the small language models to work well for use case.
Yeah. The type of documents is pretty broad. Otherwise, any documents you'd be using day to day that aren't code files really should be fine. But yeah, definitely a different target audience, I guess.
Got it.
Yeah.
Okay.
There was another one up here. Yep.
Thank you, Cooper. Very exciting application. I had a question kind of building off of related to the previous question, which is how do you deal with the huge heterogeneity of different document types, document sizes, information? Like, for example, I noticed you're producing summaries. Would you always be doing that for every document? What if it's like an Excel sheet that's just like millions of rows? Like how do you manage that kind of heterogeneity?
Yeah, that was heterogeneity. Is that right? Is that what I heard? It's currently like the text stuff is easy. You're right that like .csv files, it's going to be kind of weird to produce a summary. And some of that is just going to be, one-off. If we see people like using CSVs a lot, I think we put more effort into summarizing. But at the moment, it's LLM generated. We as Christy demoed, like in a RAG kind of way, we stuff the context and have it generate appropriate summaries. There's some trick because usually people have too many files to do that in any like reasonable amount of time. So it's an ongoing process. There's quite a bit of optimization to make that snappy. But expect better and better summaries over time for the different files. It certainly is a challenge.
Okay, thank you. Any final questions before we move on? We have another question.
Thank you. I have two questions.
Okay.
Have you ever tried with the archive, documents, how good your summaries are with respect to their own abstracts? Do they match up well? That's one question. And the second one is, have you tried the Napsack model on like Intel's newest AI PCs? Does it run faster, better, or anything like that?
Yeah, so I don't have an Intel AI PC, so I would love to.
Okay.
And certainly, like we're Mac OS only at the moment. The framework we've used gives us, the ability to release on Windows within some reasonable time frame, but it's not something we do currently. So there's that. Though I would expect the GPU to be plenty powerful. The first question about the summaries for the archive papers. I actually haven't benchmarked them yet. Like, how well do they match? It's not an easy thing to do. I've spot checked some, and it seems good. But yeah, I haven't benchmarked it yet.
That would be a good way to fine tune it too.
It would be. It really would be.
Okay, fantastic. Thank you so much again, Cooper, CEO of Napsack, and the Napsack team. Congratulations on the beta release. Super excited. Okay, we'll transition now over to Michael from Addy AI. I'm pronouncing it right, I'm just checking. Who's going to be talking about hyper-personalized LLMs. So please step up, Michael.
Thank you, Curtis. Take a minute to get set up here. Cool. Amazing. That took a while. Hi, everybody. My name is Michael. I am the CEO here at Addy AI. And before I get started, I want to talk a little bit about myself. I grew up in Freetown, Sierra Leone. This image that you're looking at is me at 7 years old with my mom. I had just won my first laptop and I was super excited. And as a kid, I've always loved building things. And then I eventually moved to America when I was 18. I went on to study computer science, and then I went to CMU, worked at AWS for a while, and now I'm starting Addy AI. So today, I'm excited to share with you what we've been working on for the last couple of months. So quick show of hands. How many of us here opened our email today? I did, you did, everyone in the room did. And this is very indicative of the entire world. Today, there are 4.6 billion users of email. And collectively, we all spend 2.6 trillion hours every year reading, writing, prioritizing emails. When we wake up, we're looking at our emails. We're commuting, we're looking at our emails. Working, we're looking at our emails. And even when we're not actively working, we're constantly thinking about, once we open our email, what are we going to do? So this number could be orders of magnitude higher than this. And we've actually tried to solve this problem as humans. Over time, we've come up with the concept of CRMs, which are just software that's meant to organize our work, make us more productive, and eventually help us spend less time on emails. It's a brilliant solution because with CRMs, you can group related contexts together and then batch email them. Really brilliant. But CRMs did not fix email. In fact, I'd argue that CRMs created more complications for email because now you have to track email open rates. You have to create email workflows. You have to create workflows, then manage your workflows. It became a giant mess. So as a team, we wanted to fix this problem. So we went back to the drawing board, trying to answer one simple question: what really is email? And it turns out that email is just a bunch of words, a bunch of relationships. You have contacts, you have coworkers. In the case of enterprises, they have customers, and a bunch of tasks, to-dos, reminders, calendar invites. So what technology, I'm going to throw the question out to everyone here. What technology do we have today that can understand a bunch of words, can understand semantic relationships, and can understand automate tasks? Anyone? LLMs, amazing. AI, specifically LLMs. Today, LLMs can process massive amounts of words, which is incredible for a text-heavy application like email. So what we've done at Addy is we've thrown away everything we know about emails, and then we've built a brand new email client from the ground up, equipped with all of the AI capabilities we have as humans today. It's going to be the world's first AI native email that allows you to train multiple AI assistants to assist you with different email tasks 24/7, from prioritizing your inbox, replying to emails, even automating enterprise workflows. This is going to save humans trillions of hours every year. And I'm excited to show you all for the first time how it looks. And here it is. Actually, here it is, and we think this is going to redefine emails as we know it today. And I'll be sharing a demo of how it works. I am currently logged in to our live platform, and the CSS has not been fully dialed in. So I'm going to be switching between our design renders and our live platform over time, depending on how things go. So the first thing you'd notice is we don't have a compose button. What gives? Well, it's 2024, we decided to completely remove the compose button and then replace it with a generate button. I don't want to spend minutes composing an email when I can have AI generated for me in seconds. So when you click generating an email, I'm going to switch back to our design renders. It gives you a box where you can enter a prompt, and then once you enter the prompt, you can define things like your tone of voice, the length of words that you want, and then it automatically generates the email in seconds, and then you can choose to regenerate it, make it longer, make it shorter. And then if you're not satisfied with a particular portion of the email, you can ask the AI to automatically edit that portion of the email, maybe make it shorter, and then it makes it shorter. And that's how that part works. I'm going to go back to the main screen here. We're only looking at 5 emails, and you might be thinking, well, where did all of my emails go? Well, when you open a traditional email client, it gives you dozens of emails. What that does is it creates a lot of email overload, email anxiety. What we're doing at Addy is we only show you 5 emails at a time on the homepage. And the AI in the background goes through all of your inbox and then decides the top 5 things that you should be focusing on at a time. It's going to take a look at the sender's information. Are they your boss? Are they your coworkers? Or is it that one annoying coworker that you never reply to? And then since it knows you so much, it's going to know exactly what to prioritize at a particular time. So it's that frequency of how you communicate with the coworkers, and our machine learning engineer, Spatika here, actually worked on that feature. So shout out Spatika. She'll be coming after me. Next, I'd like to talk about email replies. There are 2 ways we are innovating with email replies. The first way is once you open an email, there's an automatic summary of what the email is about. This quick summary is a great way to understand, well, what's the most important thing I should be focused on? What are the action items? What are the deadlines that I should be focusing on? And then sometimes you don't even have to read the entire thread. You just look at the email summary, and then you can go on to replying. This is an email that I just got. And when you're replying, we automatically give you ways that we think you want to reply to this email because it's been trained to understand you. So maybe you want to politely agree, you want to politely decline, you're being bothered too much. Lots of us receive newsletters. And then you can also provide a custom prompt if one of the things that you wanted to reply with is not available. And once you have that, the trained AI automatically generates the reply for you. Again, you can regenerate it, you can shorten it, you can make it longer, you can make it shorter. And now let's imagine it's midnight on Friday, and then you're supposed to send in a deadline for a project that you're supposed to review. Let's say a fictitious project called Project Waterfall, and you receive this 200-page attachment, and you have a couple of minutes to submit the report for this. Well, what we've built is a way that you can analyze your attachments immediately. So you click the Analyze button, and then what this is going to do is it's going to open a chat interface where you can analyze with the main points, give me a summary, and then it's going to give you a summary of the main points. And in the future, what we want to do with this is it can generate charts and graphs and visualizations. Let's say you're looking at a financial document and you want to know, well, what was my P&L last quarter, right? And it gives you the charts automatically, and then you send it to your team. It's still a work in progress. So next thing I'd like to talk about is the concept of teams. When you're working with emails, you're typically working with teams. And what we've done is we've built a way where enterprise teams can add different team members and then give them roles, which is a great way for the AI to understand organizational hierarchy. And then it also uses this to prioritize the emails that come in your inbox. You add your team members, give them organizational roles. And then the training part is actually quite interesting because as you add your team members, you also give them access to different AI assistants. That way you can have like marketing people using different AI. We all don't like HR people, so we have HR people using like a different AI, and then we have sales people, maybe customer service people using a different trained model. And then you get to select which model you want powering the AI. You can use GPT-4, you can use Llama 3, you can use Mistral, 8x7b. I am recalling all of the models that we support. And you can get to choose the language that you want the model to respond in. Another thing that we're doing is with custom instructions. You can tell it exactly how you're going to respond in particular situations. For instance, you can tell it to be concise and straight to the point. And every time it's generating an email, it's going to try to remember that. When you're adding data to the AI, lots of people have talked about RAG, so I'm going to speed run through this. Spatika is going to talk about it a little bit more. You can add information to the trained model. You can add like internal training materials. You can just like enter a URL, and we're going to scrape that URL, get all the links, chunk them, put them in like a vector DB. You can also enter local files. You can enter Google Drive. And just this week, we added support for HubSpot. So you can connect all of these, your enterprise applications, and then the AI can have information about it. And then once you've had your knowledge base, the AI can now continue to help all of the people that you've added on your team with responding to emails, replying, and automating enterprise workflows. So one of the first enterprise workflows that we are automating is the mortgage lending process. So we have these loan officers that use Addy, and they get these huge attachments via email from brokers indicating like the borrower's financial health. And what we do with it is we automatically extract the information from it using Addy. And because the AI understands the business, it can screen a bunch of these applications in seconds. What typically takes like a loan officer 20 minutes to do can be done in seconds. Well, let me see what else I have to share here. Great. So what if you're like me and now you have this amazing trained assistant, but it can only help you in email? Well, just this week, we added something called a sidebar. And this sidebar allows you to take your trained assistants not only on email, but anywhere on the web. So let's say, for instance, you're on Google Docs, and then you're still working on Project Waterfall. I don't know why I chose that name. And then you want your trained assistant to provide you with a project outline about Project Waterfall, and you tell it to generate a project outline about Project Waterfall. Enter. It's typically snappier. It's loading the model. And then because it knows what Project Waterfall is, it knows exactly where to find the information in your knowledge base. It generates the information right there on Google Drive. There are many ways you could also summon your trained assistants. One of the ways you could summon it is if you're just browsing through the web, let's say on your internal wiki, and you find some information that you want to have more info about, you highlight the text, and then you click on this tooltip here, and then you can choose to ask it about a summary. I've asked it a bunch of times about a summary, and it automatically generates a summary for you. So it's like a pocket assistant that is with you everywhere you go, and it makes it really accessible to use AI on the web. And the interesting thing is, we built all of this with a small team of 3 full-time people in about 2 months. I know there's this famous thing about Paul Buchheit writing the first version of Gmail overnight, but we're no Paul Buchheits. We're some machine learning engineers, and we did it in a couple of months. You could sign up for early access. You could sign up for early access on our website by going to this link, the QR code. But we're also looking for trusted testers. We're looking for 10 trusted testers that are going to take the product out for a spin. We want you to try it out. We're going to add you guys to our Slack. We believe that by having like an intimate relationship with the early testers, we can really build a product that saves humans the trillions of hours that we waste on emails every year and build a truly great AI assistant. So thank you so much. If you want to be a trusted tester, come speak to us. Spatika is going to talk about technical stuff under the hood about how it works. Thank you.
Thanks, Michael. And yeah, my name is Spatika, and I work with Michael at Addy AI, hopefully building the next gen email platform. And we have our, let me just get this. Okay. Yeah. So here I'm going to talk about how we have multiple email assistants and how we actually allow users to get multiple assistants and kind of control the context. So basically a RAG implementation, control the context that goes into multiple email assistants. So let me start off with, why do we think we need to offer this as a feature? And it's best to illustrate this with our, like Michael said, our loan officers are the most prominent users of our product right now. And looking at the example of a loan officer I have here, and we see assistants in this example, like he or she has two primary functions in their communications, one being customer outreach and the other being for mortgage lending. You can think of it like, I feel like most of us here have gone through some sort of loan processes where if you're a student, you've been through student loans and you have different vendors asking for what kind of, are you interested in looking for a student loan? Are you looking for a mortgage loan? So those kinds of communications require a different set of communication strategies. Whereas when you already have a customer who's looking for a pre-approval process or refinance offer, you have all these steps of mortgage lending going through into the assistant, like that the company uses as steps. You want to train an assistant which knows to answer those questions for you. So as I see how we do it, like Michael already showed you how our interface looks like, but this is a snapshot where, you know, how these two different actually can be controlled in by knowledge bases. So in our customer outreach data assistant dashboard, they can add knowledge base separate from our mortgage lending assistant. And these don't interact. As you can see, these functions are not interchangeable. The communications are different between each of them. So here the loan officer chooses to have customer communication strategies separated, whereas for mortgage lending, they have the step-by-step process for what the company has for communications in different processes. And you can add more sources. I just have a snapshot here as an example. Now, looking at a solution, I will start off with how our architecture looks like, and specifically to this solution. We have user interactions maintained by our front end, and we built it with Next.js, and we have our backend Node.js take in all these requests and handle requests and redirections to external services like LangChain, and do our embeddings with Vertex AI. Whereas all our data is mostly stored in Firebase database, where contents like the file itself, and the file is encoded and stored in our database, but the file itself, the users, the assistants that they've trained, all the metadata that would be relevant for retrieval purposes. And then we have our vector database as well. And we have this vector database in our Kubernetes container. And all of this we have hosted in Google Cloud. So now that I've showed you my overall architecture for the solution, I'd like to go a little bit into detail of how we did data processing. This might feel like a repeat from Christy's presentation earlier today, but just going over it again, we have text chunking starting with our text files, it extracts the text content, and then so it extracts text content from these files, and then we call LangChain recursive text splitter to split it into chunks. And I believe we have set different properties for these in like terms of chunk size, as well as the size of the chunks that we want. I think I just repeated myself, but the properties for recursive text splitter. And after we get our chunks, we then do our embeddings, and we use Vertex AI's embeddings models and to store them into our vector database itself. One highlight as to why we chose vector database, I feel like is already covered, but again, repeating myself, repeating content already shared before, it's like, it helps with robust similarity search as well. So in the future, we can also give our users references to where the answers are coming from, so they have more confidence in generated responses. Now that I've shared this, I'd like to revisit our user flow and what happens in our different functions for this problem. So what happens when a user is trying to add a file to this knowledge base? So first they have to select the assistant that they want to add a file to. Once they upload the file contents are stored and encoded. The encoded file is stored in our Firebase database with the metadata, and the text contents from this file is split into chunks using LangChain, and then these chunks are then embedded in using the embeddings models, and the embedded vectors are now stored in our vector database. So this is what happens in the background when some user adds a file. Next, looking at the more important part is when they try to use the trained assistant. And this is, again, the overview of RAG implementation, where we have the user send the prompt and to the selected assistant. Now the prompt has, our backend has this prompt and our assistance vectors because we stored the metadata relevant to the files. And once our similarity search is done, we get the vectors that are closest matching. These vectors are added to the prompt itself, like the context of the prompt itself. And then we have the prompt return response that is more fitting to the user because now it references data that they've just uploaded. This is our overview for how we allow users to have multiple assistants and use them to generate different emails. And I'd also like to take a moment here to talk about our open source project, LangDrive. And here we're hoping that it will also be your one-stop API to fine-tune LLMs. We already have support for a couple of LLMs right now, and you could also link Hugging Face models. So we have the pipeline set up for that. We have built-in connectors for data ingestion from Google Drive or Google Firebase and email data as well. It helps to see, we have set up pipelines, then you can use it as well since it's open source. And for deployment, you could choose to download the weights and have it set up in-house, or you could also just use our pipeline that is set up to publish to Hugging Face. And yeah, do follow us, give us a star if you like it. Our GitHub link is github.com Addy AI LangDrive and langdrive.ai, or you can just visit our website, langdrive.ai for this project. Again, call to action for our testers. We're still looking for trusted testers. If you'd like to sign up, kindly do.
Thank you. Really good presentation. It's always interesting to see the reaction on people's face when someone talks about getting a 2,000-page attachment, you know, the night before a deadline submission, right? It's like everyone gets anxiety. I could see the faces in the room. We will do some Q&A, so if there are any questions, I'm sure there will be, please raise your hands.
Yeah, quick question. I guess the question is why pick emails relative to also social media? Because as you're presenting, I was thinking, well, we spend too much time, you know, looking at social media posts and try to respond and all that stuff. Are you thinking of supporting that? And I mean, what's your take on that?
You might be expecting like a brilliant founder answer, but I struggle with emails, and I'm not a native English speaker. So every time I want to write an email, I'll ask my girlfriend to read it over for me. And then it was November 30th, I think, 2022, I was writing an email to someone, and then I asked her to take a look at it, and then she did, and she gave me pointers on how to make it better. And I was like, well, what if I put this on ChatGPT, right? So ChatGPT had just come out that same day, and I put it in ChatGPT, and I kid you not, ChatGPT gave me the exact same answer, and I was still in grad school at the time. So I opened up my computer, opened YouTube, started streaming, building an AI assistant for myself, and the live streams are actually on YouTube. I posted it on Twitter, and then Elon Musk retweeted it, and then I guess I'm building a company now, so not the answer that you're looking for, but that's the honest truth, yes.
Awesome, there's more questions.
In our work, what I've realized is we're slowly moving towards Teams and Slack. And so instead of like having hundreds of emails, I also have like 60, 70 Slacks when I wake up. So it's like emails have become where like you get all of these notifications from Slack and from like the other tools like Confluence and stuff. Like Slack is where the communication is happening. So do you fear like in the future, as we move towards more of these solutions, email is becoming slightly like outdated, slightly? I'm like, it obviously differs for other people, but at least in like startups and what I've seen is like we're slowly moving towards that direction. Do you see that as a risk to your idea, or do you think you'll just incorporate it later on?
I think emails have been around for over 30 years. They're still going strong. If another amazing platform comes along that replaces email, like Slack, it would be an easy substitution for us to do. Like I mentioned in the presentation earlier, what really is Slack? A bunch of messages, a bunch of words, a bunch of relationships, contacts, a bunch of tasks and to-dos. So any platform that has those three things, you could substitute to it.
And just by a show of hands, who still uses email as a primary messaging vehicle versus a Slack or an alternative? Who still uses email? And who uses an alternative as their primary? Okay, so it's still heavy email, yeah. Then a bunch of people that just didn't bother to put their hand up, that's fine. Okay, other questions?
I'd just like to add to that answer. Do you send professional messages on email? Sorry, Slack? Yeah. You still like. Okay. Okay. I see. Because like our first target was mortgage lending, and we feel that user base is strong email because it's more professional and personal to one customer, like one client, and they have one-on-one interactions. So I feel like for now we're safe, but like he said, what is Slack? A bunch of words, yeah.
Yeah, quick question. Let's say mortgage brokers or mortgage banking or ingesting these
files that have
right now, we are on fully Google Cloud, and we are only in dev, so we're only testing. We want to take this in-house so that we take care of the security and privacy rules, and we don't actually send these personal data to the LLMs. And that would mean having personal LLMs trained in-house. We're not at that capacity right now. We are very early, so we are thinking about that in our future.
Okay. The architecture that you showed, are you using some sort of a monitoring solution to track the correctness of your prompt, the response times, etc.?
Like after the prompts are sent, I believe GCP is kind of robust where we can see our functions and what do you say? You showed me the other day how we have analytics dashboards for the prompts. We do kind of have a dashboard. We have not set up streamlines to actually monitor, but we can go back and look at how well certain prompts are, like what is the most searched prompt, or yeah, we have that ability. We just haven't made a workflow out of it.
We'll take a couple more questions.
Hey, is there a reason you chose GCP over AWS, or did you do any kind of analysis?
I believe we chose GCP because we were part of Google for Startup and we have a bunch of credit with them. So that's why we're there. Yeah, anything you want to add?
Do you see any specific advantages with GCP, like any performance optimizations that you can do with it, which you would not be with AWS?
I don't think we've explored it. Yeah, our honest answer is we are part of GCP, Google for Startups, and they support us with their cloud platform.
Sure, thank you.
I'd like to add that Amazon's starter program only gives you $25,000 in credits, and Google's starter program gives you $250,000 in credits. So that's it.
So the real answer is after you're done with the 250, you'll move to the 25, right? It's all good. That makes sense. Any other questions? Good questions so far. Okay, we do.
So have you thought about caching your prompts themselves? Because let's say for the mortgage industry, typically there'll be the same prompts, like how much money do they earn, which school do they go, how much is their bank balance. There's no need to do so much vector database search to find similar material. It's just like take their documents, like a different version of summarize a document or retrieve from their document.
I see. I think that's a nice thing for us to think about. It feels like a nice feature. It's more like a suggestion for us right now, because I can see that use case. Thank you so much. I don't have an answer to that. But yeah, right now we do not, but that sounds like a nice feature to have because there is repetition. And that's something we can do because we have the concept of teams going on. So if they're using the same documents, they can refer the same things.
Okay, I'll take one last question if there is any. Otherwise, we'll move on to just open networking. Okay, a hesitant hand, but a hand nevertheless.
So the big difference between emails and Slacks are, Slacks are editable and social media as well. So emails, they can't. So do you allow people, the users, to edit your email summary whatsoever?
You have an answer to that?
We're only on emails for now. We only support emails. We don't support other platforms.
Yeah, no. I mean, emails, basically you can't, once you send it, you can't edit or remove much.
Yeah.
So that's a problem with emails.
Oh, yeah. So the underlying architecture of like SMTP and IMAP does not allow you to edit an email once it's been sent to the IMAP servers. So it's just the way emails were natively designed. And we're working with SMTP and IMAP protocols. The protocols were built 30 years ago, and they're still the same way today.
Okay, thank you so much to the Addy team, really exciting, and thanks to the Napsack team and obviously to the Zilliz team. Great presentations. We will be open for networking for the next half an hour. Feel free to reach out to the teams to learn more, or to obviously just network amongst the community. And feel free to reach out to me also if you have any questions on how you can participate in AI Camp. Thank you again, and one last round of applause for the speakers.